Now it's my pleasure to introduce you to a topic that I think the people first think of when they thought of the topic of the future of zoos. We've all seen a movie about it. It's Jurassic Park. And so Dr. Jeffrey Yule is about to talk about that, or at least related topics. He earned his BA from Colgate and PhD from Ohio State, with emphasis on science and literature, and then ultimately on ecology and evolution. Dr. Yule is now a professor of biology and endowed professor of applied and natural sciences at Louisiana Tech University, and his research focuses on the ecological and evolutionary causes and consequences of extinctions, with an emphasis on vertebrates. Dr. Yule.
How are we for sound? I guess okay, right? Okay. The subtitle gets at the issue of what would be going on if we were cloning extinct species. Would we be trying to replace valuable things that we lost with a sort of biological prosthetic? Or would we perhaps be wandering into a bit of a, maybe not a minefield, but a swamp? I was talking to some people on the panel, and it occurred to us that there's no obvious reason, as far as we knew offhand, that a species couldn't be both under patent and under protection by the Environmental Species Act as it exists now, so things would certainly have to change. But I thought it would be nice to give some thought to these questions, and I was happy to be invited to talk about it. 4 main areas today. We'll just take them one at a time. They're not quite equal, but roughly so. So thesis and scope. My thesis is that cloning is a potentially useful tool in the conservation and restoration toolbox. We should be considering now how it can best be used rather than waiting until later. If we plan ahead, we can avoid a situation in which cloning efforts are driven solely by human desires for things like novelty, profit, or just the desire to achieve something technologically that no one else has done. I'll limit my discussion today to extinct organisms that are most amenable to cloning, those that have gone extinct within the last 50,000 years. Sorry, Mike, no dinosaurs. And those that will go extinct the next 50 to 100. There are practical reasons for this limited scope. DNA isn't an especially hardy molecule in the environment, and for that reason, we're more likely to find DNA from recently extinct species than we are from things like, sorry, Mike, dinosaurs. Recently extinct species are also more likely to have extant relatives that can provide eggs for cloning, which you need, and then carry those eggs to term, which, so far at least, you need something to do. And then also, and this is often overlooked in discussions in the literature, as potential donors of populations of bacterial and fungal mutualists of the sort that you would hope to have in the digestive system of a healthy organism. Recently or newly extinct species are also less likely to become temporal invasive species. That's my phrase, and it would indicate a species that, newly introduced to an environment from which it's been absent, would experience explosive population growth. It would be highly inconvenient and problematic if you were able to clone a species, bring it back into the environment, and then have that species explode in numbers and then wipe out another species that you were trying to protect. Okay, technology. I don't do cloning, so I'll head off questions on that front, but I can give you some background about it that might be useful. The most important, probably, I think, is broad context, and that's just to understand that in terms of restoration biology, cloning is the least popular thing that can be imagined right now. So if you can think of the least popular group of kids at school, this would be the least popular of those. The problem is that all restoration efforts are subject to the same general criticisms. The first one is that it's far easier to prevent biodiversity loss or ecosystem damage, and far cheaper to do that than it is to mitigate it after the fact. The other issue is that if you give the public the impression that we can reverse our conservation mistakes, it's going to weaken conservation, which is going to lead us into problems. This is not my position. This is the position that's normally held, and it's a viable one and a reasonable one, too. Having said that, though, it's easy to understand why, as an experimental technique, cloning is seen as being the least popular of the kids at the unpopular table because of that fact, because it is experimental. But having said that, it's worth noting that In the last decade or so, there have been significant advances in this technology. Metagenomic approaches present a potentially useful alternative or complement to targeted single organism PCR amplification. And high throughput DNA sequencing makes the work simpler and more affordable. Right now, ancient DNA sequencing programs appear increasingly feasible for Pleistocene species, including the cave bear. This is a European species, so it's not just a North American focus. The woolly mammoth, which these thaw out of permafrost fairly regularly. It used to be they just had mitochondrial DNA from them, but they're getting nuclear DNA and sequencing it quite well. Additional species that have been lost during historical times that are at least semi-reasonable cloning candidates, and at least semi-reasonable means that people have been working with them, they've run into some problems, but over the timescale we're talking about, I think they could be achievable, would be mammals like the thylacine, which is an Australian or a Meganesian species, depending on how far back you want to go. Birds like the dodo or the huya. You could add the passenger pigeon to that, except for the fact that because it's such a, well, it was such a highly social organism that there are ecological challenges to reintroduction that would be highly problematic. I don't want to leave you with the sense that this is no problem, we can do it next week, not 50 to 100 years. The thing about futurists is that they're always promising you jetpacks and flying cars, and you always think, well, weren't we supposed to have them by now, and we never get them. Cloning absolutely is an uncertain enterprise. Even with frequently cloned domestic species, a high percentage of our attempts fail. And the attempts that do produce clones often result in organisms that have a variety of physiological and developmental problems. So even now, it's not simple. Having said that, if we were to make even half the progress with this technology in the next 50 to 100 years that we made in the last 50 to 100 years, cloning would be a much more feasible tool for extinct species restoration. Not for all of them, but for some of them, at least some of the time. All right, so where does this leave us in terms of zoos? Simply because humans could clone extinct species, it wouldn't necessarily follow that they should. I'm making a lot of assumptions here, but let's assume our descendants are at least as affluent as we are. If they are, I think they probably will. The reasons for that are primarily ethical. Aldo Leopold famously wrote, in summing up his land ethic, that a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. It is wrong when it tends otherwise. This ties in, I think, certainly with, since Leopold's death, the world has become a far more populous place with humans and far less populous of other organisms. We recognize more and more that global resources are finite, and the continued functioning of the ecosystems on which all species, including our own, depend is likely going to rely on biodiversity over the long haul. Other ecologists, we can discuss that and debate it if you want later. But as a practical matter, a sustainable human society is going to need to adopt an ethic that is at least similar to, if not identical to, Leopold's. Now, if we recognize, as we all understand already, that human responsibility for numerous historical extinctions is clear, that leads us in an interesting direction. If we add to the fact that we have a pretty strong sense that at least in some late Pleistocene extinctions, humans were liable to have been causative agents, that leads us someplace interesting. Contemporary conservation already recognizes that the environmental damage that our species causes should be corrected to whatever extent is practical. That's a perspective on writing past ecological misdeeds that's very consistent with Leopold's land ethic. If in the next 50 to 100 years, people recognize extinctions to which modern humans contributed as being our responsibility, a decision to correct those mistakes when possible would be a reasonable one. And here you can define modern to mean recent as in now, a generation or two back, or as far back as, well, 50,000 years ago, say, when the Pleistocene, late Pleistocene extinctions started in Australia. Zoos that would fuse some or all of their functions with museums and wildlife parks would be the obvious place to undertake these activities. So future zoos, as other panelists have suggested, might be more research-intensive museum-zoo hybrids, more so than they are today. All right, we're almost done. So alternatives to cloning, the first alternative obvious is to say, well, we could do it, but we're not going to. And let this be a lesson to us as a species. If you're careless, you lose things and you don't get them back. The other alternative to that involves doing something a little more active is just to translocate ecological analogs of the species that are missing. They're not always going to be available. In some cases they are, in some cases they aren't. It's going to be a case-by-case situation. But the logic would be, don't bother trying to clone mammoths or American lions for reintroduction to North America. Introduce African elephants and lions instead. This approach wouldn't necessarily radically alter future zoos, although it could, but it need not do so. It wouldn't increase global biodiversity. It wouldn't allow humans to pay back any biodiversity debt that we might have incurred, but it would help maintain current biodiversity, and we wouldn't go into further biodiversity debt, which would be, I think, a good thing. Okay, last slide. This strategy has been discussed as Pleistocene rewilding by Donlin and others. Zoos, museums, and wildlife parks could, if they wished, fuse some or all their operations to effect this sort of a strategy. So again, future zoos might be more hybrid enterprises than they are today. We may not get our jetpacks, but then again, we might.